All right, today we are going to start talking about a new term here, a new item, and that's going to be stoichiometry. So this is where we start to take the math we learned, where we were converting in and out of moles, and we start to take that information and we start to use it for something. So what do we use moles for? So first of all, the reason we have the moles is that the only way to compare chemicals is in the mole. So you cannot compare iron to oxygen without the mole. You cannot compare carbon to hydrogen without the mole. You have to have the mole, because once you get into the mole, then suddenly you can start to look at what the chemicals are going to do in terms of, okay, I started with 10 grams of this chemical. How many grams of product will that make, or how many liters of product will that make? And so that's what we're really going to be after today. We're going to be looking at things that focus in on A and B. So predict the quantity, so that's an amount of products that we expect to get based upon how many reactants. And so if you've forgotten, the reactants are just your starting chemicals over here on the left, and your products are your ending chemicals over here on the right. And look at B, relate the quantity of reactants required to get a certain amount of product. So for example, if you want like 15 grams of product, how many grams of reactant do you need? Or if you look at it differently, maybe you think to yourself, okay, I've got 25 liters of reactants, how many products will that make? And so that's what we'll be doing. We'll just be kind of figuring out amounts. Now, this is really just an extension of the last unit. And so in the last unit, we were using conversion factors, and in this unit, we will continue to use conversion factors. We will convert into moles, we'll convert out of moles, etc. So we've got 5 steps here, and I'm going to go over all these in an example, but we're going to kind of read over them first. So initially, your first step is always to have a balanced equation. If you don't have a balanced equation, nothing is going to work. Step 2, this is a step that I have students do. Not all teachers do this, but I think this is really useful. We're going to actually give ourselves notes. We're going to go in and we're going to write information above the starting values. And so we're going to go in and we're going to say, okay, above the appropriate substances in the reaction equation, so that's just a balanced equation, write the starting values and the wanted value with their units. Okay, so what that means is if you start with 5 grams of copper, we're going to put 5 grams above copper. If you want to know how much oxygen you're going to get, we're going to put a question mark over that, and we're going to say liters if they want liters. And then this is the really important thing. Any chemical they don't talk about in the problem, we are going to put an X over it because it's not going to have any bearing on the problem. And that I've found is just really helpful for students, because a lot of times you're going to have 4 chemicals, and only 2 of these chemicals are actually going to be useful. All right, step 3, we have to convert to moles. If you do not convert into moles, nothing is going to work. If you do not have moles, you have to get to moles. Step 4 is going to be brand new. We're going to use a conversion factor called a mole ratio. Mole ratio is pretty straightforward, and we're going to look at that. It's basically going from chemical A to chemical B, or the chemical that we want is going to be on top, the chemical we have is on bottom, kind of like we've been doing already, but we're going to be specifically changing chemicals. And then we're just going to convert into whatever final unit they want. And so that's kind of what we're going to do. Now, I'm going to do this example where we're going to look at grams to grams. That's the most common. This first example here is starting in moles and it's ending in grams, so you're kind of missing an initial conversion factor. But the example I'm going to work is going to be a little bit different, but we can kind of talk about this one real quick. Notice it says what mass of nitric acid. So the first thing I did is I went over here and I put a question mark and grams above nitric acid, because that's what I'm looking for. So that was the first step. Then I found that I have 0.4 moles of nitrogen dioxide. So I came over here and I said, okay, there's my 0.4 moles right above nitrogen dioxide. And then I put X's above the water and the nitrogen, because the only chemicals that matter here are going to be this one and this one, because that's the only thing I talked about. I talked about nitric acid and nitrogen dioxide. They didn't talk about any other chemicals. And so that's sort of that setup that we're going to be looking at. Now, this problem here is already worked out for you. The difference in this problem is that they already started in moles, so then they got to skip a step. I want to show you a problem where you start in grams, so you've had the full 3 steps. So we're going to slide down here, and we're going to look at this number 3 right here. Now you're going to notice that I already have the answer. Answer's there. So what we're really interested in here is we're interested in the work, the process. So first thing, we're going to read number 3, and we're going to apply some information here. So we first need to check to see, is this problem balanced? First step is a balanced equation. So this problem is actually not balanced. You have 2 NO3s on the right, and you only have a single one on the left. So we're going to need to put a 2 right there. So we're going to try to make that look a little better. We're going to put a 2 right in front of the copper nitrate. And then that's going to force us to put a 2 over here in front of this copper. So first step, we have to balance. If you don't balance, it is not going to work. So the first step we did was we balanced our reaction, because if it's not balanced, it's not going to work for you. Okay, second step is we're going to read the problem and we're going to put some numbers down. So it says, what mass of zinc? Okay, what mass of zinc? They are asking us to find zinc, and they're asking us to find that in grams, because they said mass. So what we're going to do is we're going to come over here, and above zinc, we're going to put a question mark, and we're going to put a G for grams, because it's asking right here, it's asking about zinc. Now, they only give us a single number at this point, 75.3 grams, and that is copper 1 nitrate. So we need to find the copper 1 nitrate, and we need to put 75.3 above it. So let's go ahead and find that. It is right here, and we're going to put 75.3 grams there. And now I've taken care of all the information here, and any chemical that they didn't talk about, I am going to put an X above it. So they did not talk about zinc nitrate or copper. I do not want to use these chemicals at all. If I do, then I'm going to have trouble. So I don't want to use those chemicals at all. Now, I'm going to probably work the problem above in this space to get a little more space, but these problems are often going to have 3 steps or 3 conversion factors. So first thing you do, you have balanced. Step 1, check. Step 2, we've written down the information that we want. So this was our step number 1, and this was our step number 2. What I find is a lot of students skip step number 2, and they have a lot of trouble. So this piece right here, putting in this information, we want to do this every single time. It sets us up to be successful. All right, so we only have a single number. We're going to write that down. So the number is 75.3 grams. So I'm going to write 75.3 grams. That is specifically copper nitrate. So that's going to be CuNO3. Very important to have a unit and a chemical. All right, now we're going to do a conversion factor. Times and a line. So we're going to do times and a line. There we go. There is the first conversion factor. So we are going to get rid of grams. See, I have grams right here. I do not want grams, so they're going to go to the bottom. So that's no different than what we did in the last unit. We're going to get rid of grams. If you have them on top, they're going to go to the bottom. We're going to need to convert them into moles. And so still going to have a mole in each conversion factor. So in this case, it's on the top. And then I just need to figure out what CuNO3 weighs on the periodic table, right? So CuNO3, figure out that weighs. So just go to your periodic table, add that up, and I got 125.56. So let's go ahead and put that down. 125.56. Okay, so at this point, we have basically gotten rid of grams, but now this is going to be the new step. So this is brand new. We've never done this before, and this is called the mole ratio. You'll hear us talk about the mole ratio a lot, and it's the middle step. Okay, so this is called the mole ratio. So the mole ratio is going to be the moles that you have on the bottom and the moles that you want on top. So where are we getting the moles? Where are we getting those? They are simply the coefficients or the numbers in front in your balanced equation. So there's a 2 there, and there's nothing here, so that's a 1. So the mole ratio is going to be something like 2 over 1, 3 over 2, 1 over 4. It's based upon the balancing, which is why the balancing is so important. Okay, so which one has the question mark? So the mole ratio, your question mark is always going to be on top, and then what you have or what you started with is going to be on the bottom. So we take a look here. We have a question mark. There's nothing in front of zinc, so that's a 1. So we would write down 1 mole and the chemicals. The chemical is zinc, so I'm kind of trying to avoid that spot there. So 1 mole of zinc, and then on the bottom, it's what do I have? So what do we have? We have right here, we have 2 moles of CuNO3. So we're going to put that on the bottom. So that's just going to be 2 moles CuNO3. Now you're going to have more space, and you kind of spread this out. I'm kind of stacking them a little bit. Going to give us a little more space here. And so right now, if you stopped and you got an answer, your answer would be in moles. So if they want moles, fine, you're done. But they have to ask for moles of zinc. They did not ask for moles of zinc, they asked for grams. So we need to do a third conversion factor. This is extremely common, 3 conversion factors. And so here's the last one. So what you do is you put the unit that they're asking for on top. They ask for mass. Mass is grams, and so grams go on top. If they wanted liters, put liters on top. We have moles, and we want to get rid of them. See right here? That's moles. We want to get rid of those. So we're going to go to the bottom of our conversion factor, and we're going to put 1 mole. Notice that you still have a mole on every conversion factor. It's just now the mole is not always a 1. So in the past, the mole was always a 1. Now it can be different numbers based upon what's going on in your balanced chemical equation. Okay? So we need a number for zinc. That's going to be what zinc weighs on the periodic table. So you look that up. 65.39 on the periodic table we have been using. So we're just going to put that in. 65.39. And now you have the problem, and you can run it through. So units should cancel. And so let's look. See, grams, top and bottom, canceled. There's your copper. 1 nitrate canceled. Moles cancel here and here. This mole cancels here and here. We're left with a single unit. That single unit is grams, and the single chemical is zinc, which is what they wanted. So now we do the math. Okay, how do you do the math? The math is going to be multiply or divide, just like we've been doing, based on top and bottom. Okay, to speed this up a bit so we don't run out of time on the video, here's the math down here at the bottom. So you're going to take 75.3 divided by 125.56. I usually hit enter right here, like right in that space. I hit enter, then divided by 2, hit enter, and then times 65.39. And then there you go. There's the answer that we knew we would get, 19.6, and it's 19.6 grams of zinc. Now, again, 3 steps is very common, and then this mole ratio is always going to be the new thing. It's the middle step. It's the question mark over what you already have. So we're going to practice some of these and see how we do.